Hello friends, welcome to the EduSite network. Our today's topic of discussion is Geographical Information System for Planning, and for this discussion we have with us in our studio Dr. Milak Punya, Professor, Center for the Study of Regional Development, Jawaharlal Nehru University, New Delhi. He has a teaching and research experience of over 17 years, and his specialization includes geography, remote sensing, GI, and he was also served as a scientist in ISRO before teaching in JNU. So with this brief introduction, I'd like to welcome sir. Thank you for coming to our studio, sir, and I request you to begin our today's lecture.
Thank you, Urvashi. So nice of you. So as Urvashi just explained to you, today we are going to see how Geographical Information System is utilized for planning process. Geographical Information System, many of you might be, as the word denotes, that it has two key words in it. One is a geographical, another is an information system. So, and those of you who are also familiar with the relational databases or simple database system which is there in Excel or in MS Access or SQL, they know that there is an importance of a unique ID, a unique object ID that is linked with the another data sets and could be used for further analysis. In this case, you have one more information that is attached with the database, that is a geographical attribute. So we will go through some of developments which are going into Indian academia, as well as we will also see what is happening globally. But as a researcher, since this geographical information system, along with other systems, it is widely used for research purpose, and also there are various courses that are taught in various universities. They start from bachelor's courses, like say BA in geography, where some of the courses of geographical information system are being taught. And apart from that, there are specialized professional courses that are mainly MSc in GIS and remote sensing, or MSc geoinformatics. There are various connotations for it. And then there are programs which are there in, say, masters in technology, primarily where is more focus on a remote sensing, and it get integrated. There are courses which are being taught in that particular degree with GIS as well. So as a researcher, we are always given a task to drive our own patterns from the data, and once patterns are there, we look for the inferences, and those patterns are really very important to understand first. And there could be pattern of exception, there could be pattern of similarity. And then we look for the inferences, the reason being for these patterns. And these inferences in the patterns, they help us to revise the hypothesis and to redesign our hypothesis rather. And it also helps us to look at our methodology. Is there any need to look for another methodology to answer a particular, to reach to a particular conclusion, or to explore the data further, so that are we getting a proper results or not. And we look for, along with that, we look for the explanations, and we keep on exploring our database, and the interaction from the user's level as being the expert in a particular domain, or maybe say a student from geography is interested to look into correlating high population density with agricultural land or a non-agricultural land. So he has to play with a lot of data. He has to explore. He or she has to explore a lot of data. Now, this particular slide, what you see here in this case, it is a pattern. There is a pattern that is emerging out at India level. So the first question strikes us is that what this particular pattern is. What phenomena is governing this particular pattern? On the background of this image, you see a India image, and then there is on the north you see a white color that denotes the Himalayan region. Then on the south, it's our southern peninsula, and the coastal area, western coastal area, eastern coastal area, in the south, in the northwest there is a desert, and then the northeast region. So here the pattern what you see is it represents basically annual minimum temperature and annual maximum temperature from all class 1 towns of India. Class 1 towns are the towns which have population more than 1 lakh. So this pattern, again coming back to this map, this pattern, what phenomena does it tell us? It tells us the areas like say coastal areas where there is a not much difference between annual maximum and minimum temperature, and in the desert areas where there is a difference between maximum and a minimum temperature, and similarly in a plain areas where there is a change, there is a difference between maximum and a minimum temperature. So the inference when we relate it with the location, when we relate it with the particular space or the geographical areas and their related physiography, it tells about the regional climate, what the climate that is prevailing here. So that's the phenomena. So the patterns and the secondary information or knowledge that lies with the expert, that gives a help to drive to a inference that okay, this is this particular phenomena. In this case it was a phenomena which was depicting for a climate that is prevailing over a region. Now why there has been so much talk about GIS? Now as we know, there is a growing significance of space, spatiality, location and place in social sciences, or particularly in research, and all of these things they do affect in our daily life. And majority of the schemes from the government of India and their flagship schemes have some location attribute while delivering those services, or maybe say watershed development, natural resources, managing natural resources and conservation, managing our forest, doing regional planning, and looking at what are the areas which are less developed and which are the areas which are more developed. So the space plays a major role in that. And the another, from the perspective of the social science, since maybe all scholars may not be well trained in a geographical information system approach, or what we also call in the spatial thinking, so there's need to develop a unrestricted tools and a perspective that somehow advances the spatial analytical capabilities of the researcher through the social science. It means that there need to be some tools which are readily available, where a scholar can directly go to a particular menu and he clicks on it and he gets his final output. But he also need to understand what goes behind that particular system. As I said, because growing significance of the space, location, there are some critical themes which need to be studied in a social science. So I will first emphasize on the biophysical human interface, that is on the left hand side. Biophysical human interface, if we take an example, say where the forest is degrading and what kind of interactions which are taking place with the process of degradation of the forest. So how it can be looked into? First thing is to integrate the data of the biophysical, means different stages of the forest. Different stages of the forest that will tell us whether the forest is improved or whether the forest has degraded. And what are the linkages which are there with the human, those who live around the forest or those who are part of a forest, whether their dependency is increasing in terms of the use of the forest, or whether they have developed some processes where they're also part of the conservation practices, which also there are some programs which are there in the Himalayan region, like a joint forest management approaches which are used to involve people from the participatory approaches. Another one is say urban and the regional issues. There are many issues, as we are aware that India is slowly moving towards getting more urbanized. Right now we have a population, about 31% of our total population lives in urban areas. So there is an increasing pressure how to manage the resources. So we need to have an objective information about all resources which are there in our urban areas, and along with that we need to also know how does our system works, how our cities works. It means that we need to know about the hardware of the city, and we also need to know about the software of the city. which involves education part, health part, and the employment part of the inhabitants which live in a city. Apart from that, there is also an issue of governance, and there is another important issue, that is how do we look the impacts of globalization. With globalization, as you know, that India is inspiring to achieve more economic growth, but what are the impacts which are occurring on the surface of the earth, and how to integrate that with the socio-economic data sets, and we can come up with some kind of a more objective and a realistic planning which matches with the aspiration of the people at a disaggregated level. So we will again come back to some of these problems when we first look at what is this particular technical concept, what does it mean about geographical information system, and what are the overlapping disciplines which finally enhances the capability and makes it a enabler which helps to govern, and thus how we can move towards a good governance. Now, for better understanding the structure of the lecture, what I've designed is, first we will look at the review of it, because there are existing some disciplines like geography. So as this term geographical information system denotes, the first particular word is the geographic. So what is the geographic synergy that is existing with the discipline, the native discipline or a traditional discipline, that is the geography, how they both are related. And then while doing so, we will look at intersections of various other disciplines which is happening while the formation of the synergy. And then we look at the technical concept of geographical information system. What do we mean by geographical information system, and what are the softwares which are used, and how data is generated, integrated with some other sources of the data. And then some case studies of taking into consideration of the planning. So in this particular case, what we will take is, we will take how a geographical information system can help in planning a better plan for decentralized local bodies. And primarily, we will be taking a case study of local, rural, decentralized local bodies which are governed under our 73rd Amendment, where the powers are given to decentralized local bodies, and how to prioritize the distribution of public funds, disbursement of various other resources, and also managing the resources. And finally, we will look at the prevalent trends in academia with geographical information system at local, at India level, as well as the global level. Now, Peter Haggett, he reminds us about the mapping and the spatial structures which are necessary to geography, but they may not be sufficient to describe its methods or objective. So the maps play a very powerful role. And when we talk about the maps, we have to also think about what are the mapping techniques which are involved in preparation of these maps, what kind of information these maps do provide us, because these maps become a very powerful vehicle. It's a very powerful vehicle for communication of the information, but what we see is only a map as an interface, but there's a lot of data that is behind this particular map, how this data is integrated, and there where the geographical information system, the information system part of a geographical attributes come into picture. Now, there's a consensus among the scholars, especially in geography discipline, that geography is a discipline concerned with understanding the spatial dimensions of the environment and the social processes. So it precisely talks about the spatial dimensions. The spatial dimensions, what we will see in our coming slides, the spatial dimensions for the Earth's surface, or to represent the Earth in a digital manner, could be a line, polygon, and a point, which represents the real world in a digital form, and that could be modeled. That could be modeled for various processes. That could be environmental process or various social processes, which finally result into some kind of application or some areas which could be of help of the mankind. Now, as I said, that there is a spatial dimension, and this spatial dimension is used to finally understand the environmental and the social processes. And while doing so, we finally produce a map. So what does map? Map's a map of a landscape. And the information about the landscape need to be communicated. A real world landscape, say agricultural landscape, Himalayan landscape. So a real information about that particular landscape is need to be communicated. So how do we communicate to it? So there is a phrase, how do I say what to whom, and is it effective? So there, if you look at the slide, you will see that how is a technique or the skills that could be learned. And I is basically, as a student or as a teacher or as a professor, an individual. And how do I say what is our audience? We have to also keep in mind who's our audience, whether it's a school-going children, whether it's a college-going student, or it's a senior researcher. And then whether whatever we are communicating, is it effective or not? So through Geographical Information System, various principles of the grammar could be taught how to make a map. And finally, once this grammar is correct, the map ought to be effective. So it's a combination of a communication medium as well as finally putting a man into the loop for designing this particular information, and then finally we get a map. This is combination of an aesthetic qualities which is there inherent in an individual, and then also making use of a technology, and finally putting a very powerful map that could be effective. Now this particular slide is about the Minard's map. This map is also called as the map of the century. So here in this map you can see that Napoleon's invade started in 1812, and when he started in a summer month, and his strength of his army was in absolute terms was very large. It was 422,000 soldiers he started with. But when he crossed one of the rivers, because of some event, the number of soldiers who were traveling or who were marching with him, they reduced drastically. The moment he reached Moscow, because of the cold climate, the soldiers, there were many fatalities, and many of the soldiers they died. And in between, on his return, finally he reached to Germany and the part of the France. Then finally he was left with only 10,000 soldiers. And in between, what you can also see in a flow line that there is a black line. So it denotes a particular disease that actually killed many of his soldiers. So this Minard's map, he used many variables. Say he used the width of the flow line. He also used varying colors starting from red. That denotes the seasonality. And as he moved towards Moscow, you can see there is a gradient of the color that has been used, like say from light red, then finally going towards white. It denotes that there was a freezing temperature, and because of the temperature, there were many casualties. And while his return back, you can see that again there was slight increase in the temperature, but there were various other events that happened on the bank of rivers, and there were further casualties. So in a sense, to depict his information or to communicate his information effectively, Minard used various possible grammatical variables to depict the visible representation in a better manner. So that this is how the power of GIS can be used. But in those times, in traditional times, the time to which we are referring, when Minard made this map, there was no geographical information system. So it means that we have to get some of the cartographic principles and the grammar that is built upon very solid perception properties and the cognitive capabilities of the human being into a sophisticated system. That is, again, I'm referring to a geographical information system. So it also involves the human component. That's why I said, how do I say what to whom and whether it is effective or not. So in this case, how do I say, so I also plays a very important role, because whether that particular person is capable or has gone through a technique and a learning of a cartographic grammars. Now, geographers has evolved their own ways of viewing the world, which can be summarized as three methodological traditions. One is the cartographic tradition, second is the field graph tradition, and there's a holistic tradition. It is a well-known phrase that geographer has two things very close to his heart. One is a map making, and second a fieldwork tradition. So this was a methodological tradition that was going on from quite a large period. Now, with advent in information age, with advent in capacity to do better computing with the help of available hardware, software, as well as with advent of, say, internet age. So what there is new methodologies which have actually evolved over a period of time, and many of them are inherently geographical in nature. So some of these methodologies, as the previous slide, you saw that there was a traditional approach, but there is a need to adopt now these new approaches which are really inherently geographical in nature. And as I said previously, that the many of our schemes which are implemented at a decentralized local bodies, they are also inherently geographical in nature. So these systems are, one is a Earth observation system, second is a geographical information system. Now, like there's a book by Matthew Herbert where he talks about unifying geography, where he again gives more emphasis upon common heritage and shared dreams. So he illustrated there how Earth observation system allow geography to address significant problems of society and the environment using explicitly spatial data, information, evidences, and knowledge. This argument, which places Earth observation system and geographical information at the heart of reunified geography, and I think this is not new to the academia, which I mean here the geographical academia. Now, how do we look as within the part of constellation? You can see in this particular slide that on the left hand side there are various disciplines which are listed, like say photogrammetry, remote sensing, computer science, econometrics. On the lower side there is a sociology, economics, anthropology, history. On the right side there is a planning, economics, linguistics, and on the top there is a geology, meteorology, and a biology. And in between there is an interface, there's a very strong interface of geographical space, and that could be depending upon various applications and the how do we look at the problems which are there in everyday life. They could be socio-political problem, or they are related with the regional complexities. So there is a regional group which look at a region and talks about how growth could be brought in this particular area. So they have interlinkages with regional economics group. Then there is a regional planning areas, like there is for a bigger regions or some urban agglomerations regions. The government of India has come up with various planning boards, which what we call as the regional planning boards. So what just we get out of it is that in the age of multidisciplinarity, there's a need to look at a space from a concept that provides synthesis to all disciplines to come over the space, over a region, and so that everybody can contribute, and we can finally come up with a better planning process, which is matching with the aspirations of the people or the problem of the people of a particular region, what they are going through. Now, some of other things which is needed to be looked along with geographical information system is the scale. Scale, I mean here temporal scale as well as the granularity. If find out the granularity, then there is also need to look at what scale the data is available. Now take an example in this case on the lower left corner, where fine granularity in the short run is shown. Like during Kumbh Mela, to manage a crowd, there is a requirement, and that requirement can only be filled through use of a high resolution, means large scale database of people coming to Kumbh Mela from various regions which are in a neighboring districts or within a city. How many people are coming to railway station, how many people are coming to bus stand, how many people are coming through a particular train, and that all data need to be collected very frequently within a short run, so that the planners who are there, they can manage the crowd efficiently, they can take the decisions in real time. So this is where we can make a system in place to integrate the information coming from various departments, say railways, roadways, city public administration, and also information that is coming from the space data. What I mean here, Earth observation, high resolution data, which tells us about which areas are getting crowded, which areas are not that relatively crowded, so they can mobilize their resources and can provide a better effective planning in a real time. There are other examples, but we will discuss them about later. Now coming back to definitional part, what I said as a technical part of this particular concept, as there are various terminologies which are there in academia these days. Like one is GI science, there is another term that is called geoinformatics, there is another term that is called geospatial approach, and some of the universities which are technical in nature, they make use of the word called geomatics. So now the broader term that is with advancements in technology and also how a discipline is evolving, there's a wider term that is used these days is a geographical information system. And but this system is a part of a broader system which is called GI science, and that is called geographic information science. So geographical information science is the academic theory or a concept behind the development, use and application of systems. So one of the systems is what we are just discussing about, is a geographical information system. It is concerned with GIS hardware, software, and the geospatial data. GIS, on the other hand, addresses problems and issues primarily through technological methodology, and GI science addresses fundamental issues raised by the use of GIS and the related technologies. Now what are these systems? As I said, these systems are nothing but the technologies for collecting and dealing with geographical information, and there are three systems. There could be a new system, and there could be a system of systems. So one is a geographical information system, another Earth observation system, and finally global positioning system. A geographical information system integrates hardware, software, data for capturing, managing, analyzing, and displaying all form of geographically referenced information. So there is a key word here, geographically referenced information. The geographically referenced information is basically information that has been put into a geographical framework, means it has information annotations as well as the information could be read on screen in terms of latitude and the longitude. Thus GIS allows us to view, understand, question, interpret, and visualize data in many ways that reveal relationships, patterns, and trends in the form of the maps. Now it could be concluded in the review part of this lecture that geography is a discipline of our world. Coupled with GIS, geography is helping us to better understand the earth, apply geographical knowledge to a host of human activities. The outcome is the emergence of geographic approach, a new way of thinking and problem solving that integrates geographical information into how we understand and manage our planet. Now this approach allows us to create geographic knowledge by measuring the earth, organizing this data, and analyzing and modeling various processes and their relationships. The geographic approach also allows us to apply this knowledge to the way we design, plan, and change our world. Now, coming back to systemic approach of definition of geographical information system. This is how, means once we moved from the review part of it, we made an attempt to how to synthesize is with the existing discipline. Now, GIS, as we know that it stands for Geographical Information System, is a spatial kind of information system, uses spatial information about what is where and when on the Earth's surface and atmosphere. It means it's a talk about phenomena, it talk about the locational attribute of latitude and longitude, and when, that is very good, very important component, that is time. Time is very important because time, involvement of the time with the particular phenomena tells us how dynamic particular process is. Now, there's another definition. A GIS is a computer-based system that provides the following four set of capabilities to handle georeference data. So again, the same way, there was another, same keyword was used, geographical system that enables, and finally we have to use a georeference information. So here basically the capabilities are for data input, data management, storage and retrieval, manipulation and analysis. This analysis is what we are talking about, spatial analysis. It could be in various formats. And finally, we get a very powerful mode of communication, that is map, that comes out as an output. Now, what does a GIS? GIS works with objects, their attributes, and relationship among the objects. The objects are stored in a database using geometric primitives, volume, area, lines, points. Their attributes and the relationship between them is possible because of topology. Now, we need to look into it for further understanding it, what these objects are and why there's a need to have these objects. As I said earlier also, that the world, real world, could be represented in the form of line, polygon, and the points. Now, the example you can derive from your neighborhood, like suppose you're moving towards a post office and the post office is surrounded by trees and there are various other utilities which are there. So a post office could be represented as a polygon, as a building, whereas the trees could be represented as a point symbol. And the line symbol, the approach road that you have followed, could be used as a line feature. But these information goes into the system merely as a geographic primitives, which have volume, area, points, and the lines. We need to also give some more information to it, what we call as an attribute information, means the name of a post office. If one is very particular about the species, then species of the trees could be information could be attached with the trees that is surrounding the post office. And then the relationship in terms of which particular point lies on the left side, right side of post office. So that helps, that's because of the power of a topology that brings that particular relationship in the mainframe. So we will be again seeing this particular explanation in our coming slides. Now, characteristics of the geographic data. There is a spatial data and there is a non-spatial data. As you have seen in the previous slide, the spatial data are basically geographic primitives which have a particular orientation, shape, size and structure. Whereas a non-spatial data, what I said, when you label the name of a post office, then it is information about various attributes, how much area, length and a population. So how many people who are visiting a particular post office in a particular time, and what is the structure looks like. So that all goes into the non-spatial data. Now, as you can see in this slide, there is a spatial reference, there is a requirement of spatial reference, attribute and relationships and a component, temporal component data. Combination of all these four things makes a powerful geographical information system, and this capability is developed by making use of, as the earlier definition shows, that information input in terms of where, what, how and when, and later on this information can be further used for analysis, spatial analysis, and that would result into a map. Now take an example of this particular, this is area under Jawaharlal Nehru University. So there is a ring road inside the campus, and within that ring road there are various academic schools. So these academic schools could be digitized or could be considered as a polygons, and this road that is surrounding academic block, this could be a line or arcs, and in between other information that is related with the services that is provided to the student could be depicted as a point. And then most important component, as you can see, is a time. At what particular time, what is the status of these all geographic primitives. Now in a dynamic sense, when we bring time component into it, if somebody is moving along particular road or going to a particular direction, this information can be captured and can be put into geographical information system, and finally after analysis we can produce some maps, and this is one of the example where we can show a changing the pattern that is changing with the time over a particular geographic primitive, that is a line in this case. Now the technical component of it, when we use the word feature, as I said, a feature is a representation of real world phenomena. There could be an example of a city like Delhi, and a feature type of the class of a feature with the common characteristics is called as a city. And the feature attribute is a characteristics of a specific feature that is called population. In this case it could be the population of the city, and feature attribute type is a characteristic relevant for the feature belonging to certain feature that is called as a population. Now the spatial data, and there is an inherent relationship in a georeference framework within a system, and because of the capability of a topology there is a feature relationship, and this is in a simple terms is called a logical link between the features. In this case the neighbors of the Delhi are Gurgaon and Ghaziabad. So this is how a relationship between features is formed. Now this combination of these geographic primitives as a point feature, line is nothing but it's a combination of points and arcs, and a area feature. Area feature, it could be a single polygon, it could be combination of the polygons. Altogether it makes a vector model. In a vector-based GIS, data are handled, as I said, points, and every point has a coordinate information. In this case it is x and y, that is latitude and longitude, and plus a label, that is an attribute information. The line is a series of points and in between attached with arcs, and areas are the lines forming their boundaries or a series of polygons. Now here the topological relationship also tells about which particular boundary on which side of a particular polygon, on the left or right. Now the topology is a branch of mathematics that that deals with properties of space that remains invariant under certain transformation. So how do we understand in layman language? If we draw some sketch on a balloon and we press the balloon or we twist the balloon, so the drawing that we made on the balloon, they invariantly remains the same under various transformations. When I said when we press the balloon or when we twist the balloon, the relationship between those sketches which are made on the balloon, that remains the same. Now, because of this, there are three basic spatial relationships. One is the area. The polygons can be defined by a set of lines which enclose them, and there is a property, second property, that is contiguity. Identification of polygons which touch each other or connect, identify contiguous polygons. What we said, to the boundary, which particular polygon is on the left or a right. And the third property is the connectivity. Identification of interconnected arcs starting and an end point of a network analysis. So this connectivity, because of this connectivity property that is inherent because of the topology that is possible in a geographical information system, one is able to calculate the shortest route between 2 points from the source to destination. So by making use of this particular property, we are able to divert our traffic and manage our traffic in a daily routine in a city. Now, as I said, that through this process of getting the data, input data into a particular system, and where we use for our input some sorts of information that depicts our real world. It could be existing topographical maps, it could be some other hard maps, some other information, or information that could be gathered by using other techniques like global positioning system, some devices. These days the smartphones, many of us, we carry the smartphones, and more smarter the phone is, better capability we have to collect the locational information. So every day millions of terabyte data is being collected, and that data could be put into a geographical framework, and finally we have a database that is put on the right side of the container. So the real world that we talked about through the definition of the geographical information system, that is input, getting the data into vector model through the primitive geographical primitives, point, line and polygons, and that data could be managed, and finally storage into right side what has been shown as a database container. Now, to depict further the real world, as you can see in this particular slide, that in the bottom there is a real world. The real world on the right side is shown with a forest patch, and there are two streams which are coming from the forest, highland forest, and there is a pond in between, and then there is a agricultural land, and along the stream there is a marshy area. This is a real world phenomenon. Now, with the help of this vector data, what I said, geographic primitives, we can generate information, and that particular information or that particular set of that information is called as a layer. As you, the second layer from the bottom, which shows on the right side, there is a polygon denoting forest, there is a polygon in between that denotes a water storage or a pond, then there is a agriculture, the grassland area and the marshy area that is around the stream. Now there's another model which is what we call as a raster model. Raster model, for at this level to understand, raster level is like a picture what we take these days with our handheld devices, or handheld devices like camera, or also our mobile camera, where information is stored by column and the row wise, and what we call as a digital image, which has a smallest unit that is called a pixel. So this combination of the rows and columns which makes a digital image represent the raster model. So the same real world phenomena could also be represented as a raster model. The importance of linking a raster data with a vector model is that, as I said, that geographical information also integrates other systems like Earth observation system. So this raster images could come from Earth observation satellites of different times snapshots, and this could be integrated into a system so that a analysis in terms of urban sprawl, or say changes in a cropping pattern, whether forest is degraded or not, that could be done with getting all information into one platform. Now, coming back to the major component of this particular lecture is is a planning process, and how does GIS can help in a planning. As you have seen in last 2-3 slides, that there is a real world, and this real world on the left side could be generated with the help of geographical information system by gathering information, attribute information, and spatial information, getting into one place, and then finally we can get more data from other data sources. After having a satisfactory data as per our application area, the data could be managed. Data could be managed in a sense, it could be retrieved, it could be manipulated, or it could be put in a structured manner. And once the data is there in a spatial framework, which is a geographically georeference framework, it could be further analyzed, taking into the requirements of a particular phenomena or applications which are mainly location centric, neighborhood centric, area centric, and are all spatial policy oriented. So this is how this particular cycle can make you understand that how those things could be integrated in a particular information system. Now coming back to an example in this case, like when I said there are various flagship schemes of the Government of India where decentralized planning has been used, and 73rd Constitutional Amendment Act empowers these institutions and they have a legal status. And because of all this, they have also another privilege that they can use these powers to prepare plans, and for socio-economic development they can levy taxes at a rural level, that is a village level, as well as at a district level. Now, since our decentralized planning is done at a three-tier structure, as we all are familiar with, the data is dispersed from central level. The money comes for some schemes. The resources are distributed directly to the lowest tier, that is Gram Panchayat, and it also comes through in many schemes. It's come through say DPC, District Planning Committee, and in some of the schemes which are state centric or which are developed by the state, where state devaluates those funds by making use of this existing administrative structure of decentralized local planning for urban for rural local bodies, what we call as a Panchayat Raj institutions. Now 2 decades period has been passed after 73rd Amendment Act, but PRIs could not achieve the goals. The reason being for this statement is that many institutions, they are still using the traditional approaches, and they don't have a complete system that is available into a geographical information system. Here what we mean about the public finance as well as the resources that is required to generate particular assets. And if we look at a 10 years time period, then one need to have a availability of that kind of a data which could be easily accessed, which could be easily analyzed, and which could tell us what is the potential and how does the priority of the resources should be done, so that the particular work that need to be carried out for the better development of that area, that decision should be taken. Thus there is the importance of these spatial aspects which are core to majority of the schemes in terms of activities which need to be taken are neglected. Now this particular slide gives us an idea that there means every state has their own schemes, and there are flagship schemes from the Government of India like SGSY, Indira Awas Yojana, Pradhan Mantri Gramin Sadak Yojana, Mahanarega, SGRY, MPLAD, Midday Scheme, and many others. So that is how does this decentralized rural body structure is used to approach to the last person in a village, so that socio-economic development could be brought. Now there is a composition as 73rd Amendment has empowered. There is a panchayat samiti at the tehsil level, where there is elected representatives including pradhan, up-pradhan, and panchayat samiti members. And then there is also executive structure that is available, from executive officer to the primary health center, veterinary doctor, junior engineer, what we call JTO. And then at the lowest level, that is a composition of a gram panchayat, there is a sarpanch, and then there is administrative support that is provided to the sarpanch to realize some of the plans at a ground level, secretary, patwari, gram sevak, and many others. Now the broad framework for the planning includes, as I said, and since emphasis is on geographical information system, to bring spatial thinking into picture, to bring spatial planning into picture, it need to integrate into geographical information system for having a socio-economic development of the region, where there is another yardstick that is linked with the planning is the governance, means how elected representatives, institutions, stakeholders, including citizens, and their participatory approaches can enhance the planning process. Of course, there is a need to prioritize the resources to achieve a socio-economic development of the region. So this planning, geographical information system as a planning platforms gives us all these functionalities along with a good governance. Now, this framework could be further over the region, as I said, over the region, geographical region, and what we also say in a more technical term, when we visualize a geographical framework, which is the keyword which were there in a technical term, was georeference framework. So we can integrate the data about social groups, we can integrate the data about literacy, we can integrate the data about housing, like Indira Awas Yojana in rural areas. We can have information at the Gram Panchayat about number of the BPL household. We can have also information from other sources like census about the employment, and we can also have some information from the ground level by involving various surveyors, and also by a researcher and his own fieldwork, what kind of a social capital that is there, what is the cultural value that could help to integrate the information for the overall development, primarily social development. And then there are environmental variables like prevailing land use, land cover, what kind of change has been brought over a period of time in a land use, land cover. I mean to say here, like say the diversification of agriculture has taken place or not, which particular crop is being grown, whether there is any change in the forest cover or not in a particular Gram Panchayat, what is the status of wasteland, because there are many communities which do depend upon the wasteland for their livelihoods. And then there is economic data in terms of a road network, infrastructure, ICT infrastructure, and innovations which could be brought into some of some of these institutions which are basically responsible for providing this infrastructure. And then there is approach level and the technical methodological level. We have a spatial approaches which gives us about indicators about development infrastructure, about regional patterns, about transport connectivity, and looking at the neighborhood constraints and the potentialities of the neighborhood at a basin level or maybe at a administrative level. We can look at what are the Gram Panchayat which have a similar pattern, they could be clustered together and could also be compared with the adjoining. So this is the broad framework for the spatial governance framework that could help, and that is helping already existing structure is there. Means 2 years ago there was a draft manual that was submitted by Planning Commission for decentralized local bodies and how to use geographical information system and how to make use of open source softwares to enhance and to integrate these all information on a one platform so that planning could be made. So I think today we will end up with this lecture today at this stage, and then we will take a real example, maybe by tomorrow or in the next lecture, how a particular district information could be collected and could be used for the planning and for decision making. Thank you.
Thank you so much, sir, for this clearly articulated lecture of yours. And this I would like to also tell the viewers that sir has already shared with you what he shall cover in tomorrow's lecture. So we hope that you will stay tuned, and I'd like to thank sir. Many thanks, sir, for being here and for talking to us, and thank you for watching. Have a wonderful day.